Um, we're still covering limits, but now we're introducing this idea of infinity. Okay, so we've been talking about before this idea of limits, but finite limits. Limits where there is a limit to a finite number. Sometimes there won't be. Sometimes it'll be infinity. So the next couple days we're going to talk about what limits involving infinity are. Okay, before we do that though, we talked about this. We've talked about this before with the summer assignment quiz, but it's a little bit of review. This what a vertical asymptote is. Okay, so a vertical asymptote is a vertical line of the graph that either has one of these things. The limit as it approaches, so the limit, so if it's a vertical line, it's going to have x equals something. That's the equation. The equation of a vertical line is always x equals something. Okay? In this case, it's x equals a. All right, so for it to be a vertical asymptote, the limit as I approach that line from the left side, okay, from the left side, is either going to be positive or negative infinity. Okay? That means it won't touch the line. It'll approach the line, but it'll go either up or the function will go down, one or the other. And same thing from the other side. If I come from the other side, if I come from the positive side, it can't go through. It doesn't go through it. It's not like a hole. A hole kind of just has a hole and then it goes over it. This one, it can't go through. Okay, so the limit on either side is always going to be negative infinity or positive infinity on either side. Okay, note this occurs whenever there is a value of x. Whenever there is a value of x that gives you, so this is the important part right here, a value of x that gives you 0 in the denominator, but not in the numerator. Right there. Because in a second here, I'm going to ask you the question, how do we find vertical asymptotes for the first one? And you're always going to go back to what you just highlighted. You're going to tell me exactly what's in there, or in your own words. Okay? If the value of x gives you a 0 in both the numerator and the denominator, the graph has a hole. Okay, so the graph has a hole. That's different. Okay? So if we plug in if we plug in a number, the same number on top and bottom, and it gives me 0 over 0, that means it's not going to be an asymptote, it's going to be a hole. That's another way. Okay? Okay, so first thing, find the vertical asymptote. Okay? How do I find the vertical asymptote for A? Yeah, Shristi? Yeah, I literally just said that. I said I was going to ask you that question, and I'm going to highlight the answer. Okay? So the value of x, that gives you 0 in the denominator. So just like Shristi said, we got to figure out where x is equal to 0 on the bottom. Well, how do we do that? Set the denominator equal to 0. Okay? So I'm going to set the denominator equal to 0. Solve. Okay? Add 4 to both sides. Okay? Divide by 2. X equals positive 2. So do I have a vertical asymptote at x equals 2? You have 3 options. Yes, no, yes, Here's the reason why. No, here's the reason why. I don't know yet. Which one is it? Give you a second to think about it. Is that my answer? Yes? No? I don't know yet. To be determined. What do we think? Yes, why?
If you plug it into 2x minus 4, then it's equal to 0.
Yep. If you plug it in on the bottom, you get a 0, right? I agree, 100%. But the actual answer is, I don't know yet. Why don't I know yet? Yeah, Nikish. Exactly, right? This part right here, I haven't checked this part right here. I haven't checked the part that I highlighted underneath. It said, hey, if you plug in that number to the top as well, and you get 0 on top, then it's not a vertical asymptote. It's actually a hole. So we have to do that. Okay? So when I plug in 2 up there, 2 squared is 4. Minus 1 is 3. Now I have confirmation that yes, this guy is a vertical asymptote. Okay? Be careful there because it might just be a hole. Okay? So you want to check that. There's another way of doing it. I'll show you to do it. That's one way of doing it. The other way of doing it is factor first. So I'll show you this. I'll show you the other way of doing it. So if we have f of x equals x squared minus 1 over 2x minus 4, the other way of doing it is factoring it first. If you can factor it, factor it. Okay? So if I factor, the top is difference of squares. The bottom can be divided by 2. Is there anything that cancels out? No, right? Now set the bottom equal to 0. Okay, divide both sides by 2, add 2, and you get your answer. Oops, not 2. 0, sorry. Not 0, 2. Vertical asymptote at x equals 2. That's another way of doing it. That way, I don't have to plug in 0. I don't have to check the top. I just factor it. Okay? It doesn't matter which way you do it. I don't care which way you do it. A lot of people go for the shortcut. The first way I did it is a lot less work. I'll agree, it's a lot less work. But the second way, that's the way I do it because that's the way I was taught. And to me, it's a little, it's not as, it's easier to not make mistakes. Okay. Yep. Okay. All right. Let's look at the next one. Okay, so letter B. Anytime I have, like, look at the top, look at the numerator on letter B. What's not wrong with it, but just kind of odd about it? What's odd about that? What's odd? It's nothing wrong with it, but what's odd about it? There's something odd about it. Yeah. Yeah, it's not the way we're used to seeing it, right? It's not wrong. It's a positive 1 and a negative x. There's nothing wrong with it, but it's not the way we're used to seeing it. So I look at the bottom, and I'm going to have to factor the bottom. Anytime you have an x squared plus something, you're going to have to factor. Okay? So what I'm going to do is I'm going to change the way it looks. So it's a negative x and a positive 1. Still the same thing. Still says the same thing, but it makes a little more sense to me. Okay? So I'm going to do it the second way I did it because that's, again, That's the foolproof way of doing it. A lot of times you try to plug in 0 here. This is the mistake I see students doing a lot. They solved 0. They do like we did here. Set this bottom equal to 0. Solve it, got my answer, move on. Well, they never checked to see if that was a hole or a vertical asymptote. That's why I mainly do it this way, because this way checks it for me. Okay, so I'm going to factor. Okay, I'm going to factor. All right. I'm going to factor both the top and the bottom. I'm going to factor both the top and the bottom. So the top, it's got a negative x. Anytime it has a negative x, we want a positive x. So I'm going to factor this guy here, the blue guy. So what do I factor out to get a positive x? I don't want a leading term negative. So what do I factor out? Just factor out the negative. So -1, that makes a positive x and a -1. Okay. I'm going to factor the bottom now. Let me change the color. I'm going to factor the bottom now. It's a trinomial. Okay. So in math 2 and math 3, when you were factoring these trinomials, you did different things, the x, and then you did different things to factor. I saw when you guys did your summer assignment quiz. Here, I'm going to encourage you to try to do it in your head. I'm going to try to encourage you to do it in your head, because the easier you can factor, the easier the calculus will be, right? Because this isn't calculus, this is algebra, okay? So how do you do it in your head? Well, you come up with the two numbers that multiply to be 1 times 3, that's 3, and add up to be -4. What are the two numbers that multiply to be +3 and add up to be -4? -3, -1. You don't have to worry about any numbers in front, because A is 1. If A is 1, you don't have to worry about that. Okay? Fully factored. Now the x minus 1s will cancel out, right? X minus 1s will cancel out. So x minus 1, x minus 1. So we're left with -1 on top, x minus 3 on the bottom. Now set the denominator equal to 0. Okay? X minus 3 equals 0. So I have +3. Is +3 an asymptote or a hole? We don't even need to do that, because I factored it already, right? If I did it this way, I would absolutely need to plug it back in, right? You can if you want. It doesn't hurt to plug it back in. It's an extra step. It doesn't hurt. What happens when I plug in 3 back in? I'm not plugging it into the original because I factored the original. I'm plugging it in here. If I plug it in back to the top, there's nowhere to plug it in, right? Exactly. So that means it's an asymptote. That means it's a vertical asymptote at x equals 3. It didn't ask this, but it will ask this on the test when we take it in a few weeks. What else do you know about it? We know there's a vertical asymptote at +3. What else do you know about it? Yes. Hole at +1, yeah. We got here and we got here. Again, they didn't ask for a hole, but it's always good to note that, because just get used to it, because tests and quizzes, they might ask you that. Okay. All right. Okay. I want to try letter C. Do letter C on your own. Find the vertical asymptotes. Okay, so factor. Let's factor this guy. Well, can we factor the top? It's already factored. Can we factor the bottom? Uh-huh. Yeah, that would actually unfactor it. Yeah, so we could do that. We could multiply, right? It's x plus 1 times x plus 1 and then do FOIL, right? Multiply. But then that would actually unfactor it. We don't want to do that, right? So here's my question. Can we factor it? No, it's already factored. It's already factored. It's already nice and wrapped. Okay, so we don't have to do that. All right, so since it's already factored, set the bottom equal to 0. Okay, get x by itself. What is, what was I going to say? How do I get rid of the square? Square root, okay. So square root both sides, square root both sides. So I get x plus 1 equals the square root of 0 is just 0, plus or minus 0, but it's just 0. Same thing. Minus 1, and I get x equals -1. So on the test, I put vertical asymptote at x equals -1. I put that there with all my work. I get it back, and it's wrong. Why is it wrong? Why is it wrong? Mhm. There's no hole. There's not a hole because there's nothing that'll cancel out the top. Now there's not a hole because to be a hole, there has to be that something that factors on the top, and there's not. Okay, keep thinking. What? Why would it be wrong? What's the definition of a vertical asymptote? Go back to the definition. What is the definition? How do we know we have a vertical asymptote? What has to be true? When you do what has to happen? So when I plug in 0 to the denominator, what do I, or not when I plug in 0, when I plug in a number, the number, -1 in this case, into the denominator. Oh, wait. No, wait, I'm thinking of a different problem. You're right. No, sorry. I was thinking of a different problem. If I plug in -1 in here, would I get it? Would it be 0 on the bottom? Yes, you're right. Sorry, I was thinking of a different problem. That's right. You get right. It's right. I was thinking of a different problem we're gonna do. This is the not the problem that you wouldn't get. That would be correct. Always check though. Do it in your head. If I plug in 0 on the bottom, or if I plug in that number on the bottom, would I get 0? Yeah, then you're done. Okay. All right. So turn it over. A, B, and C are exactly the same. I put D in there. D's a new one, but A, B, and C are exactly the same. Okay, A, B, and C are exactly the same as A, B, and C over here, as the ones you guys just did. What's the difference, though? Is it the same problem? No, changing it up a little bit. Now we're finding the limit. Well, what do we know about A? What do we know already about A? There's a vertical asymptote at +2. We know that, right? All right. So if I didn't know that, I would do exactly the same thing I did on the front side, right? So there's a vertical asymptote at +2. So that means at +2, there's something like that, right? If I graph it, there's something like that. I can't use a calculator to graph it, so this is the best I can do. What is our rule when we're finding limits of a function? What are our steps? What's step A, the first step we always do? Heard somewhere. Just plug and chug. Yep. Plug it in. See what we get. Okay. So plug it in. What do we get? What happens when we get 2 when you plug it in? We get undefined, right? We don't get 0 over 0. We get undefined, right? So let me put this. Can we put this as an answer then? Right? We plugged in 2, I get 3 over 0. I get 3 over 0 when I plug in 2. So is the answer going to be does not exist? No, why not? I thought that's what I told you guys. Didn't I tell you guys last week, if you plug it in and you get something over 0, it's going to be does not exist? Why doesn't it apply for this guy? Why doesn't this one not apply for this guy? Not because of the asymptotes. One thing. So what? But I told you, right? I told you in your notes last time. Let's see, where were the notes? Right here. I told you right here. 0 over 0 work left to do, right? Factor, do one of those steps that we talked about. Number over 0 DNE. But that's not the case here. What's the difference between these guys and the one we're doing now? Yes. There you go. This one's a one-sided limit. One-sided limit. This one we're only focused on one side. We're not focused on both sides. If it's a two-sided limit, follow those rules. DNE for sure. If that negative wasn't here, if it was just a blank there, absolutely DNE. But one-sided limits always exist. Okay, let me write that down too. One-sided limits always exist. Always exist. Two-sided limits, you use these. These are for two-sided limits. These are rules for two-sided limits. Two-sided limits. Okay? All right. One-sided limits, we don't have that option, but they will give you that option. 100% if you take this, this will be a multiple choice question. One of the options will be DNE. And you'll go, oh, plug and chug, oh, something over 0, DNE. It will get it wrong every time because it's a one-sided limit. Okay. So what they want to know is coming from the negative side. Coming from the negative side. It's a vertical asymptote, right? So what do we know about vertical asymptotes? If I'm coming from this side, where am I going to go? Either up or down, right? That's exactly what it said right here. I got 2 places to go. Really far up or really far down. Okay? So if I come at this line, I can't go through it. So the only place I can go is up, hug it up, or hug it down, right? Positive infinity or negative infinity. Okay, that's the only place I have to go if I'm coming from this side. All right, if I'm coming from this side over here. All right, so how do I figure it out? How do I figure out if the graph is going up the blue line or down with the blue line? Well, how do I figure that out? How do I figure it out if it's going up, if it's hugging up, or if it's hugging down? Well, let's say it's hugging up. What is going to be true about the y values as I get closer and closer to 2? They get it really high, right? They get higher, 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 higher. They're not going to be negatives, right? And what's true about the y values if I go hug down like this? They're really small. They're going to get really, really, really small. So what I'm going to do is I'm going to plug in a number that's close to 2, as close as I can without using a calculator. Okay? So let me try 0. Let me try 0. 0 is easy, and it's on the left side. So if I plug in 0, what type of number do I get? If I plug in 0 to this guy here, what do I get? Not a trick question. What do I get? Yes. 1 over 4. Positive 1 over 4? Positive 1 over 4. Okay, we're in the positive. Now let me get closer. Let's do f of 1. That's closer. I'm getting closer to the blue line. So f of 1. 1 squared minus 1 over 2 times 1 minus 4. What do I get when I do that? 0 over negative 2, which is 0. What happened as I got from 0 to 1? What happened to the y value? It went down, right? It went down. It was barely over, then it went down. So it's kind of turning downwards, right? 1/4 is like right here. Let's see, this is 1. 1/4 is like right there. And then 0. So it's kind of at here was here, and now it's here. So what's happening is it's kind of turning downwards like this. It only has 2 options. It's got to turn up or it's got to turn down, right? You could plug in 1.5. You could probably do that. Plug in 1.5, let's see. Again, this is a non-calculator question, so we can't use calculators, but we're going to be able to get close. We're going to be able to figure out exactly what's going on here. So 1.5 squared, is that a positive or negative number? 1.5 squared minus 1. Positive, okay? On the bottom, am I getting a positive or negative number? I'm getting a negative 1, right? So what's happening is it's a bigger negative. It's a bigger negative, right? So it's somewhere down here. So that's confirmation that, hey, it's turning downwards. So that means it's going down along the blue line. So the limit is going to be equal to negative infinity. Negative infinity. That's where it's going. On the positive side, I have no idea. I didn't check that because they didn't want me to check it, but that's where it's going. Okay. All right. Okay. Let's go with this one here. Okay. Anytime you're doing a limit, I don't care if it's one-sided or two-sided, you should always try plugging and chugging. If you get an answer, that's the answer. Go with it. If you don't get an answer, then we have to try something else. Okay? So try it in your head or on paper. What happens if we plug in positive 3? Or, yeah, positive 3. What happens if I plug in positive 3? What do you get? What do we get? If we plug in positive 3, what do we get as an answer? Because if we get a number, we're done. That's it. Move on to the next one. But if we don't get something, then we have to figure out what our next step is. So what do we get? So negative 2 over 0. We get a number over 0, right? So that means there's a vertical asymptote at positive 3. We already knew that, right? We already knew that because we did that over here. Okay, so let me draw a quick sketch. positive 3. 1, 2, 3. Okay. From the positive side. Now I'm coming from the positive side. So now I'm coming from this side over here. So again, I have two options. Up. Since it's a vertical asymptote, I have two options. Either go really far up or go really far down. Right? If it was a hole, it'd be different. But since it's a vertical asymptote, I only have two options from the right side. Okay? Which one? How do I know? How do I check to see which one it would be? Really far up or really far down? Mm-hmm. Yep. Plug-in number is bigger than 3. Get closer and closer to 3. See what you get. Okay? So here we go. Let's see. Let's try. Let's see. We got 3, 4, 5. All right, let's try 5. Let's try plugging in 5 first. 1 minus 5, 5 squared minus 4 times 5 plus 3. So we get negative 4. On bottom, we get 25 minus 20 is 5 plus 3 is 8. So negative 1/2. Okay. Now let's plug in 4. 1 minus 4, 4 squared minus 4 times 4 plus 3. So we get negative 3. 4 squared is 16. 4 times 4 is 16. So those cancel each other out. And I'm just ended up with 3. Negative 1. So from 5 to 4, did I go up or down? Down, right, down. And if you want further confirmation, plug in 4.5, or sorry, 3.5. Plug in 3.5. 1 minus 3.5. 3.5 squared. You can do that if you want further confirmation. But yeah, it is going in the lower direction. So this is going to be negative infinity. Okay. Let me ask you a question here. What is the answer to this? Before we go on to the next one. The limit as x approaches 3 for 1 minus x squared minus 4x plus 3. What is the answer to that question there? Because sometimes we forget. This is what we did last week. DNE. This one is DNE. This one is DNE. Why? Because there's a vertical asymptote. And if there's a vertical asymptote there, it's going to be DNE. Okay? Mm-hmm. Exactly. It's a two-sided limit. It's anytime you have a vertical asymptote and it's a two-sided limit at that number, it's going to be DNE. They can't meet. They cannot meet. It's impossible because of that asymptote. Yeah. Okay. All right. Okay. So let's do. Okay. So I want you to do C on your own. We did it on the front. You know where the vertical asymptotes are. But now I want you to do this one on your own. Okay, so we know that there's a vertical asymptote at negative 1. We knew that from the beginning, from the front side. All right, we knew that. Nothing new there. Let's see. So from the left side, from the negative side, as we get closer and closer to negative 1, so when I plugged in negative 3, I got 1/4. When I plugged in negative 2, I got 1. So it's looking like it's increasing. It's increasing. It's hugging. If you wanted to plug in negative 1.5, you could, and you would find out that it's going to be probably up here somewhere. Okay, so this one's going to be positive infinity. You don't need to put that positive in front. I always put the positive in front, but you don't need to. Just like a number, if a number doesn't have a positive in front, it means it's a number, it's a positive. So, okay. This one's a little easier. Look at the function here. What's true about any number I plug in here? Any number I plug into the function is always going to be what? Positive, yeah. So knowing that makes sense, right? I'm not going to get a negative number. How is it going to decrease if I can't get a negative number? It's only got one option, to increase. Okay. All right, last one. Last one we're going to do today. Last one. This is a new one. This is a new one that you didn't have on the front. I put one problem that you didn't have on the front that I wanted to give you because we don't know where the vertical asymptotes are, right? What's our first step? Anytime we're doing a limit, what should always be our first step? Plug and chug. Plug and chug. So plug it in. What do we get? I get a number. I don't get undefined. I don't get 0 on top. I get a number. 1/2. You're done. If you get a number and you did it correctly and you did the math correctly, which we did, and we plug it in, it doesn't matter if it has a negative or a positive up here. It doesn't matter. That's going to be the limit, right? Even if it said this. Even if it had that, the limit as x approaches 2 from the positive side, you would still get a 1/2. So 1/2. So if it's the same coming from both sides, that means the limit has to be 1/2. Okay. So this one, since this one went a little quicker, let me ask you this. Where are the vertical asymptotes? Find the vertical asymptotes. Or the holes. Or holes. Since we didn't do that in the front, do that. We're done with the problem, but since we didn't do that, since we got some time here. Okay, so where are the asymptotes? Is there one? Is there two? Is there none? What's going on here? But yeah, why none?
Because the bottom
Not decrease.
You can't get 0.
Plug in the, so if I plug in the bottom, set it equal to 0, right?
Your answer, you would get square root of -4. When you do that number becomes imaginary.
Yeah, it's imaginary. It's not a real number, right? We only deal in real numbers in this class. We don't worry about imaginary. But yeah, what number times itself is going to make -4? There is no number on the number line that's going to do that. We don't deal with imaginaries in this class. I've never seen an imaginary, so you don't have to worry about that. It's good to know. But yeah, there is no number. That can never happen on the real number line, right? So we don't have a vertical asymptote. Okay. No vertical asymptote. It means every number for x I plug in there will be a value for y. There won't be any undefined. So holes, how about holes? Will there be any holes? No, none either. Because I can't factor the bottom. Since the bottom, I can't factor it. It's not difference of squares. Sometimes people will try to do this. Oh, it's difference of squares. +2, -2. No, it's not difference of squares. Okay, it's not. That doesn't work for this guy. So there are no holes either. This guy is a regular graph without any discontinuity. Okay, no holes either. No holes. Okay. Alrighty. All right. Okay. Tomorrow I'll give you some more practice, like I did last week. I'm going to give you some practice out of this, and yeah, that's it. Okay. And then Wednesday we'll move on. Wednesday we'll move on to the next section.